Hi, good morning. This is a pretty new kind of topic, something that is like in experimentation, something like that. Well, my talk is about computer vision, K3s, that is a kind of Kubernetes, small Kubernetes, and some special devices for neural networks. Um, well, this is me, Sergio Méndez from Guatemala. I am also a professor. I am the organizer of the Cloud Native Meetup in Guatemala. Guatemala is next to Mexico. I also work on DevOps stuff, LinkedIn ambassador, CNCF ambassador, and author of a book about edge computing. So that's my reason to be here. Well, edge computing, just to have some basic concepts before going to the technical part. Maybe one of us, we are looking to experiment with hardware, Kubernetes, and that kind of stuff. So my idea is to present this as simple as possible. So edge computing just refer to process the information near to the source of the data. Just that, keep that in mind. So if we talk about edge computing, we can think about different layers. So we can communicate devices with the cloud, let's say. So we can represent edge computing with 4 layers. The cloud layer, let's say where AWS, Google Cloud, Azure lives there, or maybe a private cloud is there. The near edge is the place where let's say the communication happens. The telcos, the SMS messages, routers, and that kind of things. The far edge refers more to the part where the devices are located near to the source of the data. So in that place, you can find small devices like sensors or small edge devices that are provided with microcomputers like a Raspberry Pi, and some sensors using microcontrollers that refers more like something like Internet of Things or IoT. So in the tiny edge, you are going to find sensors and that kind of devices. So in the far edge, you are going to find the clusters, but edge clusters. Let's say in this case, I have a device here in this podium. Let's say. So this is the small cluster that I am going to use. So let's say that this thing is near to the source of the data, and it's going to process the information, right? This is the far edge. And maybe if I want, I can move that information to the cloud and watch that information around the world. So that's basically what edge computing does. Artificial intelligence, maybe one of the people here play with or are working on artificial intelligence, so just like basic concepts. As we know, artificial intelligence can give like autonomous power to think, let's say, to a program, to a robot, to a machine without human intervention in most cases. So in artificial intelligence, there are like different kind of science like mathematics, statistics, linguistics, and a lot of things applied to different use cases. Some things applied to video analysis, voice analysis, to try to replicate human behavior, and that kind of systems, let's say. So one part of our artificial intelligence is to study the rational agents. So what is an agent? Well, let's talk also to machine learning. Machine learning is a type of artificial intelligence, like the name is saying, is the machine that is learning about some topic in specific. So machine learning, how it works. You are going to read data or have some input data to do predictions using that data. So you have to have some historical information in order to predict using that information. As we are working with spreadsheets on Excel, you know that there is an option to do a kind of linear regression, and that's the most simple way to do a prediction, let's say. So artificial intelligence using models can do the same thing. And there are different algorithms that right now, for example, using scikit-learn, you have access to a lot of pre-built algorithms instead of doing that algorithm or programming all the things by yourself. Yeah, so it's easier right now. So computer vision, because we have the concept of machine learning, the machine that is learning about something, computer vision is more applied to video analysis, image analysis. So you are going to learn from images and predict when you are trying to read some image, you are going to do a prediction, let's say. Just is like a different kind of application for machine learning, computer vision, but it's in the same context. So computer vision is a subcategory of artificial intelligence that detects objects, maybe movements, and is also applied to traffic systems, let's say, to predict or watch out what kind of traffic jam is moving around the city and that kind of things, but it's not the only kind of use case for this kind of applications. So right now, an agent, what is an agent? Having all or putting all the things together, it's like a kind of, as you can see in the diagram, looks like a kind of robot. So has like a brain or the rules based on AI. Yeah, a lot of people say is that AI is a lot of ifs. If something else, and using some random stuff. And that's true in some way. So you build the rules in the agent that gets information with sensors, the perceptions. So with that perceptions, let's say that you have a table of rules, and you trigger some action over that perceptions. And you are getting that perceptions around your environment. This could be the environment, and let's say that I have the sensor in my eyes, or to hear something, or taste something, and maybe you can support that perception using the effectors like arms or legs, let's say. If you think in a robot context, could be like easier to understand what is an agent, right? The effectors, the arms, the legs, and the perceptions, eyes, sensors, right? So a neural network, let's say that in artificial intelligence, there are information that you can classify, like category 1, category 2, 3, and 4, and etc. And there is information that you can classify, right? So for that kind of information, like images that are not represented at 1, 2, and 3, because it's a lot of information, you can use this kind of specific kind of algorithm, neural networks. So that's the specific use case. If you cannot classify the information, use this algorithm. There are another algorithms, right? But this is like the common algorithm that people is using to resolve that kind of problems. So neural networks, as the name says, try to simulate the neural networks in the brain. So you are going to find in artificial intelligence a lot of algorithms that try to imitate something in the nature. Let's say that how the bees are reproducing and a lot of internal things. Let's say neural networks is one of that cases. And some biological behaviors, let's say, in the nature. Neural networks are represented like this. I got this information, well, using like some cool source like IBM. But let's say that you have some input information and you have some kind of, a lot of ifs, let's say, or random information that is moving around like different layers or generations of information in order to polish or give a final result. How many layers? It depends on how you are going to define your algorithm, let's say, and how you are going to train the model. Neural networks are like pretty heavy to compile the models and that kind of things, but right now they are also pre-compiled models that you can also download, for example, in the TensorFlow page and that kind of things. Now it's easier. Like, for example, ChatGPT is like a pre-compiled model that you can use right now. So this is like the kind of representation of neural networks. So what is a neural network accelerator? That's different. So we are looking like a kind of algorithms that help us to analyze video and image analysis, let's say. But a neural network accelerator, let me see. I have another one here. It's pretty small, but it's like a kind of USB. It's just that. Well, there are another representation of these devices, like a kind of a small device that you can connect inside your machine, your desktop machine, and that kind of things, like a RAM or something like that. But let's say that basically what it does is like an external GPU or extra GPU specialized just for processing that kind of information. So of course you have to have like a driver and some software that can use that device to process your information. So basically what it does is speed the processing when you are using this kind of algorithms, let's say, just an external GPU. There are like different devices available right now. This one is one from Intel, is Movidius neural compute stick. There are another ones. I was watching the page at Intel, and right now are deprecated. They are moving so fast, that technology, just like an experimentation kind of devices. For example, the Orange Pi AI stick is the same thing, and the one that I saw that is like pretty stable right now is the Coral USB accelerator from Google. So that's the device from Google. And right now I am using the Coral device, the one that you can see here, like, it's like a kind of USB. So because I love Coral devices, no, it's like pretty stable. I think that you can program in something and that can be living like a year and they are not like changing all the thing every time. So the one that I have is the first one in this side. There are other devices like a small Raspberry Pi, something like that, and other ones that looks more like a RAM piece, and another small devices. So you can use whatever of these devices you want. Sometimes they are using these devices just for prototypes or prototyping something. Just remember that if you want a production-ready device, you have to take in consideration that the device is going to be outside, receiving raining, the cloudy, and sun, and a lot of things. You have to take that in consideration. And for example, NASA is like using Raspberry Pis for the space. So if you prepare the device, you can use it. Yeah, as I was mentioning about these devices, they are also like a kind of GPUs, let's say, just to speed the information there. Some computer vision use cases, just like in general words, not to be too specific. If you need something to classify the image, could be a use case for computer vision. If you need to detect objects, could be computer vision, or tracking the movement of an object, computer vision too. Something that you can get or analyze in an image can be computer vision. So that's the reason of the traffic systems. Smart traffic systems could be like computer vision. Kubernetes, by this side, can give you the power at the edge to deploy your applications, manage your applications, and scale your applications. Yeah. And update in an easier way, and also adopt DevOps best practices on your edge applications. So K3s is a small version of Kubernetes that you can use to deploy your applications at the edge. Let's say that the edge, when you are using microcomputers, is more like you are referring to edge computing. If you are using microcontrollers like Arduino, you are using more something like IoT, right? Just to keep like, it's not the same thing, but close, right? K3s can give you like a lot of powers, enough stuff to run a Kubernetes application, right? K3s is part of the CNCF Sandbox projects. Well, can give you the automation as I mentioned, and some cluster configuration that you can consider is like to have a single node cluster or just a machine running K3s. Like this example is pretty common on edge computing application to have only one node. Well, I have three, but I am using one, right? So, and the multi-cluster configuration that maybe you can process or you want to do something more complex, right? ARM, that's the choice for the right microprocessors because talking about power consumption and power processing is like balanced instead of Intel. Intel just like a lot of energy. So for example, you have your device in a farm or something like that and you are using a battery. If you are using Intel, they are going to be not enough for that device. So a Raspberry Pi, an ARM device could give you like a long time with less power, let's say. So that's the reason to choose ARM. It's more balanced. And also that's the reason that the smartphones use ARM. Because Intel, if you just have a smartphone with Intel, the battery is going to die so fast, right? That's the reason of using ARM. ARM has different flavors, different versions. The V7 version is like the 32 bits version. The V8 is like the 64 bit for applications. I am using the V8 version and the Raspberry Pi 4B. So I think that you have more options using 64-bit applications, more software available, and that kind of thing. So keep that in mind. Different operating systems, Raspbian, Ubuntu, etc. Raspbian is like the most completed operating system for these Raspberry Pi devices. Another thing that you have to consider when doing edge applications is that you have to compile for ARM. It's not like the same you have to compile to Intel, no, right now for ARM. For example, in the artificial intelligence stuff, it's pretty common to use Python. So you can also have to find the right libraries using ARM. If not, this is going to be incompatible and it's not going to run your application, right? Just, you have to spend some time on that. Some alternatives, because of the pandemic, the Raspberry Pi was like pretty expensive. Right now, I think that have the correct value right now, but there are some other alternatives like the Raw Pi, Pine 64, Orange Pi. There are some production-ready devices for Azure, and I think that Azure has a pretty awesome cloud platform for edge devices and IoT and that kind of stuff, so could be like really nice to see on the internet. And some example that I included in my book that was experimental was like, this is a car, right? So the car is reading with a camera what it's going to find during the driving time, like a semaphore and pedestrian and cars and that kind of thing, and it's going to alert the people. So this application has a display, a traffic that is showing in a screen, a part of inference to predict about what the application is reading from the camera, and that kind of things, and getting some GPS information, right? So what it does is like showing a map with the objects that it's finding when you are driving and that kind of applications. And as you can see, uses a lot of layers. The cloud layer to store the information, a public map that all the drivers can access, a car that is reading information, like scanning the street, let's say, and detecting objects. And because of the GPS, the satellites are moving around and getting information, and that's the kind of complex system that you can build yourself for edge computing, right? But in this talk, I am going to show a pretty basic example. This one is like pretty complicated. Also, when I was like writing the code. So the challenges of computer vision is like speed processing for images. How much speed do you need to process your information? The ARM support. how to reduce costs, like using the less power that you can, the resources for your devices, and also the power supply. Pretty common challenges for computer vision, also for edge computing or edge devices. So we are going to create a simple computer vision application to classify bird images, right? So let's create the system. This is how it looks. Maybe you can see in detail, but this is my single node cluster with the Coral device and the power source, and that's it. I am using my smartphone as a router, but when I came here, the internet doesn't work in this level, but I changed my Raspberry Pi to connect to the Wi-Fi here in the brewery. So now it works. I have it like a video. I will try to do the live demo. Requirements, a Raspberry Pi OS Lite 64 based on Debian Blue for this year, because changed a lot. Maybe a Raspberry Pi 4B with 8 gigabytes could be better, and a micro SD card as faster as you can buy, like the read and write speed information for that. If you buy like a slow SD card, your Raspberry Pi also will slow when reading and writing information, so that keep in mind, and the power source that I have it here. You can also turn on a Raspberry Pi with the smartphone charger. How to prepare your device: install the operating system, create maybe a SSH file in the micro SD card for Raspbian, configure the network. You have to enable these flags on the kernel of Linux to activate the power to create containers. If not, it's going to fail. Install the Coral libraries in your device, because we are using Coral from Google. Then restart your device. Then you have to configure that libraries inside. This information is coming from the Google for the Coral devices, so maybe can change, right? Once you have all installed, well, you can clone my repo that I am going to share here. Then you have to install K3s. Once all the device has the initial setup, then you should build your container image. Well, I have prepared some container image already, but with my user, or maybe you want to build your container for yourself with your modifications. Then get the IP address for your service. And finally, test the application for get some inference. Okay, let's do it in real time. Yeah. So, as I am connected here in the brewery, okay, it's running. Maybe the complicated thing sometimes is like you need access to internet in order to run this thing. There are another installation of K3s called AirGap that doesn't need internet, but it's more complicated. So try to have the things as simple as possible. So let's say, as our instructions say, what is the service of this application? It's running there on this IP address. So here is the URL for the inference one. Let me show you the code. Okay, so I have different birds. I have an owl, a quetzal, an eagle, and another birds, right? So the code, let's explore the code first, because I know that you love Python. It's a pretty, let me see, pretty basic code, a Flask application, an API that right now I am calling a bash script that runs a Python code, just to have the things as simple as possible, running the CLI there and returning the result, right? let's explore the bash script. No, hold on. This is now, okay, the classification number 1, okay, it's going to call Python with this algorithm that is coming from Google, and it's going to say that it's going to use this pre-built model with TensorFlow Lite. TensorFlow Lite is TensorFlow for edge devices, let's say, pretty lightweight for that, and it's going to send information to classify birds. And for the classify number 1, there is a parrot. For the classification 2 algorithm is like an owl, then a quetzal, and then an eagle, right? So let's run our code. It's coming from the Raspberry Pi. And okay, that's the result. So it's taking like 5.2 milliseconds for that. The first one is like a parrot. The second one is like an owl. The third one is a quetzal, as I remember. Yeah, this quetzal that, I see that you remember the quetzal, that the green bird. And the fourth is an eagle, bald eagle, okay? So something interesting is like, for example, let me change something. Okay, I am using like the blue inputs for USB there that are like USB 3, and I changed it to the USB 2. Because like it's important how the speed changes when you are using these devices. At least on these devices you can see the difference. So let's see how many times it takes. I hope it works. Okay, that's the difference. So on edge, depending what devices are you using, the speed is going to change. So this is how the information is moving across this Coral device, right? So I think that I have like 3 minutes for questions. Just let me finish this part, maybe. Okay. Yeah, I think that I have time. Just let me show you this. This code is in this repo. This is just experimental thing, right? Or maybe you can move it, these kind of things onto production. The slides also, and the resources. And let me show you something. In the repo, you can see the all the algorithms, the images, also the YAML for the application. Let me show you. Pretty basic application on Kubernetes, right? Pretty simple. You can replicate this code, right? So if you have questions, I think that we have like, what? No.
Yeah, we don't have time, but
we don't have time, but
we can take one question.
I'm going to be on the at 1:45, right? In the pub.
Yeah, in the pod.
Yeah, I'm going to
Obviously.
give 5 books for free if you want. So, and we can also talk about this thing, right?
Okay, there's a time for one question. No? Good. Thank you so much, Sergio.
Okay.